Here we have a very challenging question. And if you see this on your next SAT after watching this video, you're going to be really thankful. Let's take the first hint that they're giving us here, which is that f of -9 equals f of 3. Now, f of x is the height. F of some number is the height at that number. So they're telling us that the height when x is -9 is equal to the height when x is 3. Let's just imagine for now that those two heights are around here, but we really don't know. We just know they're the same heights as each other. But that's really telling because parabolas are symmetrical. And so if we know sort of two even moments on the parabola, we therefore know the axis of symmetry. Because for the vertex, the x value of the vertex will be equal to -b over 2a. If you have it in an ABC form like that. And the vertex is also equal to, the x value of the vertex is also equal to the average of the zeros, or the average of any two moments of the same height. So for instance, if I had this zero and this zero, I could kind of do the same thing and say, well, the vertex must be in the middle there, right? But if we know two equal heights, we can do the same thing. We can say, well, the x value of the vertex, that must be -9 plus 3 divided by 2. It must be the average of those two symmetrically spaced out points. So that's -6 over 2, and that's -3. So we know that this right here is x equals -3. Now we said a second ago that the x value of the vertex is -b over 2a. So looking at the equation they gave us, if we say -b over 2a, that's the same as -4 over 2 times their letter a, which happens to be in the a spot anyway. But we found out a second ago the x value of the vertex is -3. So now we know the value of a because we have an equation in one variable. So let's just go ahead and solve that out. -4 over 2a is the same as -3 over 1. Cross multiply, -4 times 1 is equal to -3 times 2a. Divide by -6 on both sides. A is positive 2 over 3. So is a greater than or equal to 1? No, it's less than 1. It's 2/3. Now, what else can we do with the information we're being given? We know this thing opens upward. So from the very beginning, we would have known that a was a positive number at the very least, because if a parabola looks like this, it means its a coefficient is greater than 0, positive. And if a parabola looks like this, it means the a coefficient is less than 0, negative. But the vertex is at hk while it's opening upward. Now, are there any other clues we're getting here? K is less than 0. What is that telling us? So if our vertex is hk and k is a negative number, well, that's our height. And our height is negative. So it actually turns out that the picture I drew so far is accurate. We don't know how far below the axis it is, but we know that this point is below the x-axis. Now that's really critical. If the vertex is below the axis, the parabola opens upward. Putting those two things together, we know that there are two solutions. So let's type that out. If the vertex is below the x-axis and the parabola is opening upward, put this all together to say there must be two x-intercepts, otherwise known as solutions. Now, why does that matter to us? Because the number of solutions for a quadratic is a reference to the idea of the discriminant. If you have two solutions in a quadratic, it means that the b squared minus 4ac of the quadratic must be greater than 0. So let's play that out a little. We know that the a is 2/3. The b is 4. The c is what we don't know. So if b squared minus 4ac is greater than 0, let's get a little room going here, then that means that 4 squared minus 4 times 2/3 times c is greater than 0. Let's simplify a little faster. 16 minus 8/3 times c greater than 0. 16 greater than 8/3 times c when you add the 8/3c to the other side. Now multiply by the opposite fraction, 3/8, 3/8. And on the left, we can cross simplify. 8 and 16, divide them both by 8, and you get 2 and 1. So now we have a 6 on this side greater than c on that side. Flip it around, c is less than the number 6. So that's what we know. We know c is less than 6. Do we know c is less than 0? No, we don't. If the number 6 is right here, and this is a graph of the possible values of c, well, we do know for a fact, based on everything that we've done so far, we know that c is less than 6. It can be 5.99. It can be 1. It can be -3. So in other words, at the end of all this, we can say c can be negative, but we cannot say that it must be negative. In math, the word must is a really important word. It means that we know for a fact this is going to be the case. We know for a fact that c is going to be less than 6, but we don't know for a fact it's going to be negative. So neither of these things are true.